Okay, hello to everyone. So my name is Maël. My slides are in French, so if you speak English, just listen to my words and I will explain everything anyway. So I will talk a bit to you about Yarn. So first, who am I? So I work at Datadog, and before that I used to work for Facebook. And in this context, I started to contribute on Yarn, the package manager for JavaScript. So I spent 3 years working on it, and during this time I also happened to make some work on Flow itself. So I have some context on both Flow, Yarn, and TypeScript because we recently switched to TypeScript, and I wanted to talk a bit about this. So first, Yarn got created in 2016, and in that time, TypeScript was still very far away from what it is currently. There wasn't that many people using it. And we wanted the Yarn codebase to be strongly typed. So what we decided to do was to go with Flow, which was developed within Facebook. So we had a lot of experience with it. So it was a success. It led to less bugs, which meant that we could iterate faster on the application. So overall, it was a good choice. Over time, some problems started to appear. So the first one was in terms of tooling. Inside Facebook, we had access to some pre-built tools, such as Nuclide, which was an extension for Atom. But outside of Facebook, our external contributors had a lot of issues working on Yarn, mostly because of Flow. Another issue was that it made it difficult for people to contribute to Yarn itself. And another issue was that Flow has a lot of idiosyncrasies that are specific to its goals. So the Flow tries very hard to be a sound, which in French can be translated by strict, but it does this at the cost of user-friendliness. So for example, that's an example I really like. So imagine that you have just a function that takes a string and prints it. And you have a type user that contains a name. So what you will do is that you will check whether your user has a name, and if it does, you will print it. If you do this in Flow, you will get an error saying that you cannot call print with user.name because the name might be null. And by reading this code, you think that, wait, why? There is no way. I'm just checking for null. And Flow is actually kind of right, because what happens is that you're calling console log, and console log can be anything you want. Console log might have side effects, and Flow will tell you that, yeah, since you're calling a function, it might change the content of user, so no, just do your check again, or store the variable so that you can keep the inference, and that's right, that's correct. But it's not user-friendly, and in 99% of the case, it does not matter. So it means that you're making your development harder for the sake of cases that practically don't happen. It makes sense for the Facebook codebase, which is huge, but it doesn't make as much sense when working on an open source project, and you just need to encourage people to contribute. So to summarize, in my mind, soundness is only a key word. It shouldn't be a grand plan. So what I expect from a type system is to be able to iterate quickly, to have confidence that my code will work, and that it makes it easier for other people to contribute to my code. I'm not looking for soundness per se. Soundness is just a tool that helps with those three items. So everything is a trade-off. In security, you don't have perfect security. And it's the same thing with type systems. You can only have as good as you can until the cost starts to outweigh the value. So we switched to TypeScript. And it was a good choice because it led to better contributions by people who stayed. And it made our build system simpler, since we didn't have to go through Babel itself. We could remove a bunch of things from the build pipeline. And it also led to out-of-the-box integrations with editors, such as VS Code. So that was overall, a great choice. We also were able to integrate it with plug and play, which is the new install strategy that we are developing in Yarn, so that we don't have non-modules. You might have heard of it. And lastly, it was kind of a subjective decision from me, because I felt like that over time, TypeScript would have more success than Flow. And again, since we wanted to acquire more contributors, then it made sense to use the tool that all our prospective contributors were already using. So since I felt like TypeScript would have more users, I decided to go with that. By switching to TypeScript, we decided to go very far in typing again, even more our code base. And so one thing in Yarn 1 that we did wrong was file system access. File system access is a pretty difficult thing, especially for a package manager, because if you use the standard APIs, it's not typed. For example, let's say that you're running code on Windows or Linux. You will not have the same behavior if you use the standard path model. On Windows, you will have backslashes, and in Linux, you will have forward slashes. It's not a huge thing, but it makes your code undeterministic. And everything in Yarn is supposed to be deterministic. So we wanted to fix that. And on Windows, so I said that we have those backslash classes. But are they really important? Why can't we just use Unix path even on Windows? So that's what we did, basically. We decided to go with what we call portable path, which are statically typed kind of path that our own FS layer only accept, meaning that we never get to make a read file sync, for example, with a path that didn't came through one of the functions that convert path from not portable, native, to portable. To give you a quick example, here we have a small snippet that takes the file name, which is native. It contains backslashes, it contains the drive letter, and converts it into a Unix path. Then later, when we need to actually use it through the Node.fs API, we just switch it back into a native format. And since we have this FS layer I mentioned, we just have to actually use the FS layer with the portable path, and everything will work. Even better, since everything is typed, if we try to send directly a string or native path into the FS layer, TypeScript will tell us that no, you cannot do this because your path is susceptible to contain backslashes or drive letters, making it non-deterministic. So that's the kind of thing that we did with TypeScript. But even though it was we spent a lot of, even though we had a lot of success, not everything was great or still great. For one, the watch mode is not as good with TypeScript as it is with Flow. With TypeScript, the watch mode is just basically the incremental mode. Each time you run, each time you change a file, TypeScript will still run the type check on all your files. It will try to cache a few things inside the check, but it will still need to retype check everything, making it very slow. With Flow, it's kind of different because you have a daemon that is able to track the dependencies between all the files. So if you change one file, Flow will not recheck everything. It will only recheck things that actually changed. And that makes a lot of difference. Another problem with TypeScript that we had is that, so you might have seen the state of JavaScript 2019. And one of the numbers from this survey is that more than 50% of the JavaScript user base is using TypeScript. So that's great, especially for this meetup, right? One of the problems that comes with that is that since TypeScript has more than 50% of the user base, it means that all their work is affecting a lot of people. So they don't have a lot of leeway on breaking things or innovating. On the other hand, if people want to try something new in terms of tooling, it has to work with TypeScript. There is no other way, because otherwise it won't work with more than half of the JavaScript ecosystem, meaning that nobody will practically use it, right? So it means that since the TypeScript compiler is not extendable, a lot of innovations are gated behind the TypeScript team. Fortunately, they are aware of this, and they have been trying to find a solution to make sure that people are not stuck. So there is the plugin API that they are thinking about. So I think that this will be unlocked on the long term, but still it's something to keep in mind. In terms of future between Yarn and TypeScript, we want to build better integrations between package managers and TypeScript. So for example, something that we noticed by developing Yarn with TypeScript was the problem of add types packages. Usually, when we wanted to add a package, to add a dependency to a package, we needed to check whether whether it shipped its own types, or whether there were types on the add types repository, definitely typed. And we needed to check which version we needed to add, and that was kind of a problem. So what if the package manager was just able to, when you had Lodash, see that Lodash doesn't ship its types, see that there is a add type / Lodash package, and just add types Lodash directly into your dependencies. So that's what we did with a Yarn plugin, which is optional, which you need to install yourself. But so once you have installed it, Yarn is able to automatically make this kind of help. Similarly, we have been able to add support for plug and play directly within TypeScript, but it's supported and maintained by Yarn itself. Maybe at some point it could make sense to move that to the TypeScript chunk. So that's the two main things that we are looking at. So let me show you a quick example of what I meant with this plugin thing. So imagine that I'm creating a new project in TypeScript Paris. Here. Then I will create a new project with Yarn in it. Now I will use Yarn add in order to add a, let's say, left pad, right? Oh, I forgot to run Yarn install. Of course. Oh, I see. Here it is. So usability, right? So I run Yarn install. So everything is good. Now let's say that I'm adding left pad. Yep, indeed. So if I look at my package.json, I have left pad, but I don't have the types of left pad. Now, what I can do is that I will first run a Yarn plugin import with Yarn pkg plugin TypeScript. So it downloads automatically from our repository the version of the TypeScript plugin. And once we do that, we just have to run Yarn add. So we said Lodash, right? Let's try with Lodash. And here you can see that Yarn has been able to automatically install not only Lodash, but also the types package. And if we look into the package.json, everything got saved as you would expect. So that's pretty nice, because as soon as you want to use TypeScript, so it takes a bit of time because the TypeScript package is pretty large. Thankfully, everything is cached once you download it. So in practice, it's actually very fast. I just cleared my cache just before the presentation in order not to use a hot cache and cheat. So I will create a quick tsconfig. And now if I call TSC, the TypeScript compiler, so I should get an error telling me that, yeah, because there are no type definition for, oh, yeah, presentation, right? So, let's do it again. Okay. Okay. So left pad actually has types, apparently. That's a good thing. But for other packages where you might need to add the add types packages yourself, Yarn is able to install them automatically. So that's what we want to do, basically, to decrease the amount of friction that you need to go through when creating new projects, be it TypeScript or regular JavaScript. And I think there are a lot of experiments that are possible in order to reach this state. So that's my talk. Thanks for listening. If you have any question about Flow or TypeScript or how we switched from one to the other, or Yarn too, feel free to ask me. I will stay around. Thank you. There's one question.
Hi. What was blocking you for doing the same native abstraction for parses in Flow?
Sorry?
You made a path abstraction for in TypeScript.
Yeah.
Yeah, but what was blocking you for doing the same in Flow?
So it wouldn't have been impossible with Flow. Clearly, I think both type systems are very similar. Two main things about Flow is that, so one important thing about Flow in particular is that it is written in OCaml. And OCaml is a very different language from JavaScript. And when you want to contribute to Flow, you really cannot, because it's very different. I've been able to spend hours, days sometimes, trying to figure out why some very small one-line change wasn't working, and trying to fight the compiler in order to understand that, oh, yeah, right, of course there's a type somewhere that is broken. And when you figure out the problem in your line of code, then you feel very smart, but you still lost a few hours or days of work. So contributing to the Flow code base is very, very difficult, meaning that in practical terms, it cannot be accessible by all the contributors that we want to work with. So in this case, for the path library, it was not that it was impossible to do with Flow. It was just that working with Flow would not have been able to satisfy the other requirement that we had on the project.
How long did it take to migrate from Flow to TypeScript? Is it just renaming the files, adding tsconfig, and it's done? Or you had to change some types? And
no, in our case, it was a bit different because Yarn 2 is a completely rewrite from Yarn 1. But in general, I think that migrating from Flow to TypeScript is not that as difficult as doing it the other way around. You still cannot just change the extension and expect things to just work. Flow has a lot of utilities and syntaxes that are slightly different from the TypeScript counterparts. But for example, the code that I shared at the middle of the presentation is something that wouldn't work in Flow, but would work in TypeScript. And the way you would fix it for Flow would make it work, would work as well with TypeScript. So there are no strong incompatibilities with the type when you use them, but when you author them, sometimes, especially with generics, it becomes quite different. One problem though with Flow is the number of third-party typed packages. So for example, let's say that you have a bunch of dependencies in your project and you want to migrate from, if you want to migrate from Flow to TypeScript, you will not have this problem. But again, if you were to migrate the other way from TypeScript to Flow, then a lot of dependencies wouldn't have types. Any other question? Good.
So, hi everyone, my name is Anton and I am a software developer at JetBrains. Or to be more precise, I am an IDE developer. So I am a person who sits behind the screen and draws some red or yellow or green or other colored lines in your code, suggesting that you could have written some piece of code better, or you can convert it to some modern syntax, or, and that's more important, when are you sitting comfortably in your chair and drinking your coffee or tea, I am moving blocks of code so that it changes while you're enjoying your next cookie with that tea. So this talk is about how to help me doing this work while you're still enjoying your tea and you are not interrupted from that. So So this is about how to refactor your code in TypeScript, or how to write your TypeScript code in a way that it's easy to refactor. And first we need to discuss what is good code. That's quite an abstract term. So if your code is green in tests, if it compiles with TypeScript, if your QA team approved it, and if it's deployed and at least works in your browser on your computer, then maybe it's a good code. But when we are starting to think about some long-term perspective, what happens when one day a new person comes to a team and decides that some entity which was called name before now should be called last name. That could be a new architect or just a new developer who decides that last name sounds better, or it could be a new database and you need to map your entities in code to that new database. It could be any circumstances in which you want to switch from name to last name, and what do you want to achieve afterwards is that your code is still that good code that we discussed before. So it still works. And TypeScript, of course, helps a lot us with that, because with TypeScript type annotations, that's quite easy to link entities in your code and to update them simultaneously when that's needed. But TypeScript is a structurally typed language. And with structural typing, we have a lot of troubles in sense of how your code is updated by tools. So you know all that TypeScript is a powerful language, and you can declare a type with two properties A and B in an infinite amount of ways. Here are just 7 ways of declaring the same type. You can declare a class, type alias. You can use string literal types and iterate over them using a map type, or you can use an enum with string literal values and also iterate over them with a map type, or intersect types, make unions and all the stuff, and you will achieve the same result, the same structurally. And while discussing refactorings, I will cover today only the rename refactoring because it invokes a quite important feature of any IDE. That's search for usages. Because in case when you want to rename name to last name, what happens? First, we stay here. So we need to find the actual declaration. So thanks to that type annotation, we know that P is person, so we find this declaration. After we have found this declaration, what do we need to do next? We need to find all the usages of that declaration. And that's also quite easy with TypeScript in this sample, because we have this that relates to person, we have this type annotation that relates to person. So finding usages in this case is nice, and also any IDE has some index of names. So when searching for name, we won't process all the files in your project, but we will process only those files that contain that name. So that speeds up things because we need to load code model for each file we process. And let's discuss a little bit different case. And we have two variables, and each of variable has a type annotation, and those type annotations are the same. And we have an assignment somewhere x to y. And now, how does TypeScript process that? Of course, TypeScript is a structurally typed language. How it behaves? It computes types of x and y, and checks if they are assignable. Assignable means that in the worst case, we just iterate over all the properties, signatures, and check for assignability of their types. So in this case, all the checks pass because they are actually the same types, so they are assignable. But what happens when we try to rename that A in the first type annotation? Your code immediately breaks and it won't compile anymore. Why? Because, well, if you recall what we discussed when discussing rename, what do we need to do? We need to find all the usages of that A. But there are no usages of that A, so there is nothing to rename. This is not a usage of A. This is just an assignment of one variable to another variable. So we have only one declaration. Okay, we have the second declaration, but we don't know how to relate them, because the only way to relate them is to process this assignment. But with this assignment, how to relate them? We will need to compute all the types of all the entities in your code, in all the files. That also will break the optimization I mentioned before with indexes based on names, and that will take ages, so that you will cancel the refactoring and just invoke find and replace, because it will work much faster and will be more convenient than here. So the first thing we want to discuss here is how to avoid such a situation. And the best way is just to declare every entity in your code only once, because structural typing allows to declare entities in many places of your code, same named entities with same types and all that. But when you will need to modify your code, if you have them in different places, some of them accidentally won't be updated, although you maybe expected that. So if you define only once and use everywhere, that will lead to no breaks in your code. And also that will speed up the type checking, because we don't need to compare property sets anymore. We just have the same type and that's it. Then a bit different, although example, but the same problem actually. When we have structurally compatible types, and we have two types, each of them declares a property called name. And if you are being lazy and you don't want to modify that code, so you just declare a new type with one property name, of the same type, and you use it as if it were a super type of those types, because it works with TypeScript. So you can pass instances of either worker or manager in context where an employee type is expected. And now what happens if we want to rename any of that entities? Again, there are no usages in our code. There are no usages of the field name here. Absolutely no usages. So renaming any of the usages will rename only one of them, but all the other usages will be left unchanged. And that's not what you actually wanted to achieve. So the best way to avoid this problem is just don't intersect types only in your head, because tools are robots and they are not that intelligent to read your thoughts. Just use inheritance if you can use inheritance. That's a good old mechanism of relating types one with another. Or if you don't have access to the code of those classes, worker and manager, use union types, because tools can relate types if they are constituents of the same union type. So that's also the way to deal with that. But speaking of unions, intersections, and other composite types, here we also have a small issue, and that issue happens when you have properties with same names in different components. I mean that with union types, that's not an issue, because when we have a union type and we invoke rename here, it's quite clear that we should rename both declarations, because otherwise your code will be broken, because union otherwise won't have this property at all. But if you have an intersection type, then if you invoke rename here, it's not quite clear what to rename, because we can rename the first property for you, we can rename the second property for you, we can rename both of them for you, and as a result we will have some valid code. But is that what you expected? Is that what you didn't expect? We don't know. So in the best case, we will show you a dialog with a set of checkboxes which you need to check, which declarations to update. Again, with composite types, there is the same way to avoid problems if you use inheritance. For example, if you have the same property in several components of the same intersection, but if they are related via some supertype, that won't be an issue because we know how to relate them. And of course, it's much better just to avoid using intersection types in case when you have properties with the same names in different types of that intersection, or mapped type, generally speaking. And also, just don't ignore hints we give you. I mean the tools, the IDEs, when you are doing rename, because if you are renaming such usages, more than likely we will show some dialog or some warning or give you some hints on how to update your code. But if you will still fail with checking all the checkboxes properly, then just ensure you have tests for such code if you still have to use such pattern. And one of our favorite subjects, I mean IDE developers, because when you are using string literal types, that's the hardest thing to update ever, because you have some string that passes through all the type transformations, and it is used somewhere as property name, and you invoke a rename of that property name, and we should update that string. In some particular cases that is possible, and in case like here, when you declare especially a type alias enumerating all the literals you use, some tools will support the rename, but not the others. And also when you are using pick and omit types with string literals, some tools won't rename such occurrences because it's also a bit not trivial how to relate them with declaration. Well, with Speak it's quite trivial because its second argument is a key off of the first argument, so that's okay. With omit type, the second argument is unconstrained, so we needed to add some hack to treat it as a key of the first type. With string literals, you also have several ways to improve your code. So, for example, if you define type aliases for sets of literals, at least our tools will update those usages. I mean WebStorm and ReSharper, because we specially implement support for that case. But if you use some more complicated type combinations with literals, we won't process such usages, and sorry about that, but that's not possible in the general case. And maybe the easiest way, if you have a set of literals that you are expecting to use as property names, just declare some fake type, which you really didn't need a type there, but you can declare a type with properties named after those literals, and just key off that type. In this case, any tool, I mean really any tool, will update such properties because they are properties, they are not strings. That makes a difference. Or you can just use string valued enums and avoid using literal strings in your code in most contexts. So to sum up what was being said, what can't be refactored won't be refactored, because in case when we can't relate some entities or when we lose track of the source of any entity in the code, we won't update such entities and your code will be broken after the refactoring. And to sum up all the things about how to improve that from the side of your code, you can declare all the entities only once. Use inheritance where it's possible. And when you are dealing with composites, try to avoid situations when you have intersecting property sets. I mean composites, intersection types and map types. And don't let your literals stay without any context. So here by literals, I mean not only string literals, but also object literals, array literals, because when they are used in the context of some other type, they will take the type of their context, but otherwise they will introduce their own type, and such usages also won't be updated properly in many cases. So some samples of what users wanted us to rename, update, etc. This is a sample taken from TypeScript Backtracker, a bit modified sample. And the user has an interface doc, what a coincidence, with a field name. And he uses this name in a big type. And there is a key of argument of a function where name is used as a string literal, and here it is used as a property usage. So the user expected that all those 4 usages will be synchronously updated. This ticket is marked as design limitation because the compiler can't track sources for some of these entities. And I would say that we implemented special processing of this case, but only this particular case, because we can track key types of some other types, especially. I will tell a bit later about that. But still, in general case, that can be broken. And a bit more crazy sample, when a user wants to use a value of some property, string value of some property of an object type as a property name in another type, and also as a value. And all the 3 usages are expected to be renamed synchronously. No, sorry. And here is also one interesting thing about what I was talking about, declare once. Here species declare twice, but that's okay because they are joined via a union type. So this usage will be updated properly, This usage will be updated properly because it's extends animal. These usages will be also updated properly because of the contextual type. But here is a duplicate declaration of the same extent species in extends clause of some generic, in extends clause of conditional type. And this is actually a duplicate declaration, and this will be the only usage that won't be updated at all in between all the other usages. So is that bad code, those code samples? Well, I won't say that's a bad code. That's a code that is really hard to maintain, because when you need to perform a single change, it can kill your code, and you will need to manually update so many places in code that you will get tired quickly and fall back to find and replace maybe. So what I was talking about when I mentioned key types, key types, as an IDE, we actually can't do the same job as the compiler does, because the compiler's main aim is to validate your code and to produce some output. And generally, that's almost all. And so that's why TypeScript treats string literals only as a string literal types, because that's enough for the purposes of validation, because it checks that this name is contained in key of this doc, and that's all. But to properly update such usages, we need to specially track them. So we extend type system of TypeScript with some special type key type, which relates that name with the type doc, if it originates from one of such contexts where they are related. So actually an IDE may have richer type systems than TypeScript, and it's no longer standard TypeScript in general sense, but it helps with updating your code. So to repeat some things once again, tools will work well as long as every entity in your code is trackable. If there are some declarations that are not trackable, or in some sources that's not clear what to update, in sense that updating some of declarations, some other declarations will lead still to work in code, but maybe that's not what you expected, but we can't guess what you expected really in this case. And in case of implicit usages, like from our very first sample, when we had X equal Y, when we had no real usage of property name, but it was implicitly used, and that's why it can't be updated. How to update your existing code to make it more updatable? Just use refactorings to make your code more refactorable, because there exist such nice refactorings as extracting interfaces, superclasses, type aliases from types, replacing all the occurrences. Or you can replace type aliases with interfaces, or you can replace a type alias that enumerates some set of literals with a string valued enum. That's also quite possible using refactorings. At least some tools provide one refactoring, some tools provide other refactorings. You just need to research which tools provide which of them. And specify types explicitly, infer types from context. That also helps a lot making your code more updatable, because in some cases, for instance, you will want suddenly to add the return type annotation to not break your code after adding some extra return statement, and yeah. So why I discussed all those things? Because TypeScript is not a type system in itself, but it's a tool for creating your own type system in your code. So you can describe your types in many different ways, and it's up to you how to do that. So it's more of a design problem. So when you're writing TypeScript code, you should always keep in mind how your entities are related, and maybe that would be good for us, but at least try to do so. Maybe you should also keep in mind that all the entities in your code are explicitly related, so that the tools won't fail when they need to process those entities. So you need to be smart enough to create a good type system for a project, but you need to be not too smart to break tools. Thank you very much for your attention, and if you have any questions.
Okay, so hi everyone. I'm going to talk about Angular with JHipster. First, I wanted to ask you a question. Who here knows Angular? Okay, good. And a JHipster? Oh, okay, nice. I'm going to start by introducing myself. My name is William. I work at Hypo Technology as a full stack consultant. I will be freelance next week. I'm the stream leader on the Angular part for the JHipster project. I'm part of the core team contribution. And I'm a big fan of JavaScript and its ecosystem, including, of course, TypeScript. So what is JHipster? JHipster is an application generator, so we can generate for you an Angular, React, or Vue.js application with a backend with a Spring Boot. Who here does some Java code? Okay, so it's a Java backend, so I'm not going to talk a lot about this, don't worry. But basically, we manage for you the authentication, the multiple languages, entities, deployments, microservices, and continuous integration and continuous deployments. I'm going to do the focus on the front-end stack because we are at the TypeScript Meetup. We have the same stack for the three frameworks, React, Angular, and Vue.js. So for the build system, we use Webpack. We don't use the CLIs. We don't use the Angular CLI. We don't use the Vue CLI. And we don't use Create React App, I think that's the name. We did our own Webpack configuration because we wanted to customize it to do some performance tuning. And the CLIs doesn't yet allow that, so we prefer to go this way. We, of course, use TypeScript for the three frameworks. Angular has the best support for now, of course. And for the unit test, we use Jest. And for the styling, we use Sass. So some focus on TypeScript. So as I said, the three frameworks are all written in TypeScript. And one new thing we had pretty recently was the strict mode who was enabled on Angular. I will explain it after. So let's go for a demo. I have not the same skills as the previous speaker, so I will code with my two hands. Okay, good. Can you hear me good? No? No? Better? Okay. So I am on an empty folder. I'm going to tell, maybe I can zoom. Yep. Spoiler. That's better? Bigger? Okay. So basically, JHipster is a command line. You can install it with the npm, Homebrew, Chocolate on Windows, and I think that's it, but I think that's enough. So I code it by using the JHipster command, and I'm just going to add a skip check command to avoid some network calls because the network is pretty slow on my phone. So now JHipster is going to tell me some questions, ask me some questions about what I want to do. So as I told you, we support different architectures, monolithic or microservices. For now, we will go to the monolithic as is the simplest way. We only deploy one application and not a more complex architecture. We can customize the name of the application, the Java package. The JHipster registry is a side application. It's more useful for the microservices architecture when you want to monitor and scale the whole microservices architecture. Sorry. So for this simple example, we won't use it. The authentication, we have 3 types, JWT, HTTP, OO2, with a Keycloak, which is open source, and Okta, which is proprietary, I think. So let's use JWT. The type of database, so we support both relational databases and NoSQL databases. Let's go with SQL. Let's use Postgre. For development, to prevent from starting like a Docker file or a Docker container or anything while developing, we ask you if you want to start with an in-memory or a disk-based application, which will start when you run your server, so you don't have to run your Docker before starting your application. So let's go with that. Spring Cache, we don't care. Same, it's Java thing. These options are some other technologies that didn't fit, like these are no yes, no questions. These are various technologies that we integrated. So we can use Elasticsearch to do some search. So we will generate, if you check this option, we will generate for you both a search bar on the front-end side, and we will do the indexation on the back-end side, and we give you the data from the front-end to the back-end. You can do WebSockets, Kafka, and OpenAPI to generate from an OpenAPI file, which is the new name of Swagger. So basically, you import your Swagger file, and it will generate the Java code and the front-end code for you. And then you have the framework. You can see there is no Vue.js yet, because it's in, for now, it's in a blueprint. It's like an extension of the generator because it's still a work in progress, but it will be soonly merged into the main generator. You can also choose, by the way, to have no client at all. You can use also a Bootstrap theme because we use Bootstrap for all the styling parts. We don't use yet Angular material. We will maybe soonly propose it if you want, but for now, people seem happy with Bootstrap, so we keep it. And so you can use a custom theme if you want. I will go with the default one. If you want to support multiple languages, you have a default one, which will be the fallback if you don't give the translation for another language. This one will be the default fallback. So it will be the English, and let's French, and I don't know, Greek, Hindi. And we give you also, we generate also some unit tests with JUnit and Jest. JUnit for the Java part and Jest for the front-end part. But you can also do some performance testing with Gatling. You can do some functional testing on your APIs with Cucumber, and you can do some end-to-end testing with Protractor. And then we have a marketplace, but I will talk to you after about this. So now it will generate some files, quite a lot. And as npm install is going to take like 5 hours, I already generated an application. I did the same thing like an hour ago, just to show you the results. So I started my application using Maven, and then you will get this. So it's the basic application, really the blank one. You already have, so it's not the same languages I chose, but you have the different languages. You have the authentication, admin. And then once you are logged as an admin, you have various front-end application, front-end pages like user management, metrics of your Java application, of your web server, like the requests, the time of each request. You can have also the API using Swagger. So you have all the API, so you can try your API. You have a lot of things. It's not the point of this meetup to show you all the pages, but you have various information about your application. And you have the authentication, which is working as always. Once we generated a simple web app, what we want to do is to generate some entities. So to generate entities, you have two choices. Yeah, it's still installing, so let's switch. You have subcomments on the JHipster, so you can do JHipster entity foo, and then we will start asking you if you want a relationship, what are the fields of your entity, etc. So it's quite long. If you have like 5 or 6 entities or more, it can be quite long. So we decided a long time ago to do a domain language, which is called JHipster domain language, JDL, to design your it's like a UML schema, and then you import it, and we will generate all the API endpoints and the front-end code for you. So I already imported on some tool we have. It's the JDL Studio, which allows you to write the JDL code. Is that okay? You can see it? Yeah, that's fine. So you can write it, and it will, on the side, you will have the visualization of your model. So I copy-pasted a model from our CI to test all our different cases, etc. So that's the basic application we always generate when there is a pull request or etc. So it's basically a bank account system, very basic. You can see if I just put my entities with the fields, the types, of course. These are Java types. You can add some validation. The validation will be done on both the backend and on the front end. You can add enumerations, and at the end, you will have the relationships if you want one-to-one, one-to-many, many-to-many, etc. And you will see the result here. Once you finished the design of your model, you can download by clicking here the JDL file, and then you will just have to type the command import JDL with the path of your file. So let's do this. I think it will work even if it's still installing. Maybe with Yarn it was faster. By the way, you can run it with Yarn. We have a flag, a JHipster -- Yarn. You can run it with Yarn. I don't have on my machine, so. Oh, I didn't do the skip checks option. So now he's scanning my file. So you can see that he detected all the entities. And now he will write some files and erase some white, because basically Liquibase is the database. So he will have to add some tables on the database. So he will have to update the database. So that's why he's asking me to overwrite this file. So let's go and overwrite everything. Again, I cheated. So the application I showed you has already all the model, but it's to gain time. It's not. Oh, it's finished. Oh no. Oh, because yeah, we ran a script after, and as the npm installation hasn't finished. So yeah, let's keep it. So I have the very same JDL file imported, and we can see I have one menu per entity, and it's basically just a crude interface, so I can see my entities. And yes, also I forgot, by default, we generate some data some dummy data by using a library called faker.js. So it will detect the name of your entities. For example, if I go to employee, it will detect that my field is first name, so it will generate real data like some names, some emails. So it's quite nice for the demo. And it's only in development. Of course, we want to generate data in production for you. And so I can see my entities generated. I can view it. I can edit it if I want. I have a relationship between my employee and my manager. I can change it if I want. I don't know what I've done. Yeah, I changed the manager here. So yeah, it's basically really basic, but it's a good start. And I think it's a code that we will always write. It's not the most interesting code we write, so we think it's better to automate it using clean code with JUnit test, just test, basic front-end pages, and then you can start working on what you are paid for is bringing business value on your application. So let's see first the code which was generated. So you have. Do you prefer the dark theme or the? This good? Okay. Yep. That's okay. So we have various configuration files. We give you also Prettier. I don't. Who here use Prettier to format the code? So we give you this with the configuration, with the commit hook that will format your code instantly. We have also the ESLint file already configured for you. And we still have TSLint. I know TSLint has been deprecated, but for the Angular users, we still have to use TSLint because some Angular specific rules has not been yet switched to ESLint. So we still have this one, tslint.json file, but once Codelizer will be switch to ESLint, we can remove this. So the source code will be on the source main folder, and the front-end code, which interests us today, is under the web app folder. So on the app, you have all the TypeScript code, all the Angular code. On the contents, you will have the style, the images if you want. On the internationalization folder, you will have all the JSON file we generated to if you want to change it. And then you have the index.html. And we also provide you the front-end application is already a PWA. So it already works offline. I didn't try if we cached the API calls, but at least the application login is working. So that's it about the app. After that, it's a pretty basic Angular application. So let's talk about the strict mode. You can see that here it's enabled on the tsconfig file. Yep, it's here. So strict mode is a TypeScript compiler option, which enable, which enable following option: no implicit any, no implicit this, etc. You can see it there. For me, the most interesting rules are the no implicit any one, the strict null checks, and the strict property initialization, because they force developers to type their code and to always check if a value returned from a function or from maybe from a function is already defined before accessing it. So let's show it with some basic example. So about the no implicit any, this rule is pretty basic. I can take code like I'm on an Angular service, and here if I omit to type this parameter, TypeScript will tell me, yeah, this type is implicitly any, so you have to type it. Of course, I can be lazy and do that, and it will work. It doesn't prevent us from from putting some any's in our TypeScript code, but at least it will tell you if you have it implicitly. So let's pull it back. About the strict null checks, it's quite interesting if you do something about that, like you do an array, then you try to find something in it. All right. And then you want to access, let's imagine it's an object, and then you want to access, oh, what? Okay, new features. Yeah, now he will tell me that as the find is not sure to return a number from my array, it will tell me that this value is possibly undefined. So I have to check before with like an if or with the new operator from TypeScript 3.7, I think. But we don't support it yet because Angular don't support it yet. So, and if you want to force it, if you are sure that your value is not null, you can use the strict non-null assertion operator, which is the exclamation mark. I discovered it quite recently, and I was quite surprised. But by using this, you tell TypeScript, before you were saying that my object is possibly undefined, now it's not. And the strict property initialization finally is on a class. So I just have to find a model on my entity, I think. Yep. Yeah. So basically here, if I declare a field on a class, it will tell me that there is an issue because I didn't either initialize it in my constructor and didn't initialize it inline, like doing this. So again, if you are not happy with this, you can do that. Is to force you, this rule will help you to check if there are some unused fields on a class, for instance. I think that's it for me. Thanks. Any questions?
Okay. I have one.
Thanks.
No. I have
you have one. Okay.
You told us about jest.
Yep.
What's the test command of the project?
npm test.
Yes, but okay. But it launched jest under the hood, or is it the Karma Jasmine like an Angular?
No, it's jest. Yeah, we use jest. We used like 2 years ago Karma Jasmine. Okay. Then we introduced React, and as jest is the common solution. And I tried jest on the Angular application. It was pretty much faster than Karma Jasmine. So we decided to put jest on both Angular and React.
Second question.
Yep.
I saw an AOT test.config.json.
Yep.
Does the template support AOT?
Yep. Yeah, we support AOT and we support the new strict mode on the Angular 9. I already tried it. So we are pretty ready to use Ivy compiler even. It already works with Ivy.
And then last question.
Yep.
Is the OpenSPI spec valid? Meaning that do you generate a specific client for the API?
A specific client for the API?
Yes, because do you read Swagger.json?
When you import it?
Yes. How are the DTO generated? Your class?
No, we generate all the code from the JDI file I showed you. We don't do special checks about Swagger. I think the Swagger is from either some annotation on the Java code. I think. I'm not an expert on this. Sorry.
Is it possible to launch the command line utility
afterwards to change language or database from backend?
No,
you have to make a new project and migrate.
You can upgrade with the same stack. There is some way to do it, but it's quite difficult. The way we recommend to avoid issues with upgrading, if you want to upgrade, like when you release new versions, it's to do inheritance. You inherit our classes, our models, and everything. So you try to avoid touching the generated code. For the front end, it will be pretty much impossible. But for the back end, it's what we recommend. Otherwise, you have to do another project with another technologies. We don't provide the way of switching databases. It will be too complex for us.
Okay.
Okay. Thank you very much.